Welcome to my presentation. In this presentation we shall try to solve system of linear equations in three variables, and I'm going to, since the procedure is a little longer, I'm going to divide it up into 2 or 3 parts. This is part 1 of this presentation. So the system of linear equations in 3 variables, we'll take an example, and this is how an example looks like. I'm just making up a system of linear equations in 3 variables. 3x plus y plus 2z is equal to 31. This is equation number 1. And then the second equation is x plus y plus 2z is equal to 19. This is equation number 2. And then the third equation we have is x plus 3y plus 2z is equal to 25. This is equation number 3. We want to write an augmented matrix based off this system of linear equations. The way to do that is as follows. Step number 1. We're going to pick up the coefficients of x, y, and z in equations 1, 2, and 3 and write them down in a matrix format, and that will be our augmented matrix. So that will be 3, 1, 2, 31, and then 1, 1, 2, 19. Those are the coefficients of x, y, and z in equations 1 and 2. And then in the third equation, it will be the coefficient of x is 1, the coefficient of y is 3, the coefficient of z is 2, and the constant number is 25. This is our augmented matrix. This is our augmented matrix. And our goal, I'm going to write that as step 2. Our goal is to obtain a goal. Our goal is to obtain a row echelon form of this nature. We want 1, A, B, C, 0, 1, D, E, 0, 0, 1, F. So we want to make sure that we have ones along the diagonal and then zeros below the diagonal, like that. And that is what we want to achieve. So now we will try to use the row operations procedure and then try to simplify this process. When we look at this example here, we can interchange the rows. We can interchange row 1 and row 2. Since we have 1 in first row, first column already, which is available to us in the second row, we can interchange row 1 and row 2 like this. 1, let me write it in this manner. 1, 1, 2, 19. We are writing the second row as the first row now, and we're going to write the first row as the second row, which is 3, 1, 2, 31. And the third row will be the third row. We're not changing that. 1, 3, 2, and 25. So we have all that laid out. What we want to achieve here is we want ones along the diagonal and we want zeros along below the diagonal, and we will try to achieve that one at a time. First things first, we want this location to be equal to 0. So the way to do that is as follows. We'll call that as step 4. We'll call that as step 4, and we will use the row operations to try and achieve that. So we have 1, 1, 2, 19, and then the way to achieve that is we're going to take the new R2 is going to be equal to minus 3R1 plus R2, and that will do it. So to achieve that, we're going to perform this operation. Negative 3 times 1 plus 3. 3 plus 3 is equal to 0. Then the second element here is negative 3 times 1 plus 1, which is equal to negative 2. And then the third element here is negative 3 times 2 plus 2. Negative 3 times 2 is 6, negative 6. Negative 6 plus 2 is negative 4. And then negative 3 times 19 plus 31. Negative 3 times 19 is negative 57 plus 31, which is equal to negative 26. And the third row comes down as is. So the third row is 1, 3, 2, and 25. So this is what we have. And if I were to write this in a neat manner, this is how it's going to look like. This is how it is going to look like. We have 1, 1, 2, 19, and then we have 0, negative 2, negative 4, negative 26, and then we have 1, 3, 2, and 25. So this is the matrix which we have obtained after the row operations. And to make sure where we are on the finish line, we want ones along the diagonal, we want a 0 there, we got that, we want a 0 there, we want a 0 there, we want a 1 there, we want a 1 there. So first things first, we'll try to get a 0 in that location. Okay, so this step is going to be step number 5. Step number 5. We want a 0 in that location. So therefore, we're going to write it out in this manner: 1, 1, 2, 19, and then 0, negative 2, negative 4, negative 26. We didn't change anything there. And then in here we're going to come back and then say the new R3 is going to be equal to negative R1 plus R3. Negative R1 plus R3. So that will be negative 1 plus 1, which is equal to 0. Negative 1 plus 3, which is equal to positive 2. Then negative 2 plus 2, that is equal to 0. Then negative 19 plus 25, that is equal to 6. So therefore, we have, this is what we have achieved. And the way, if we were to write it in a clean manner, this is how it's going to look like. We have a 1, 1, 2, 19, and then we have 0, negative 2, negative 4, negative 26, and then we have 0, 2, 0, and 6. We have just written this down in a clean manner without any of these calculations here. And this is our partition line, and this is the line we are looking at. We want zeros here, we got there, we got that, we want a 0 here now. In the next step we're going to perform is we want to achieve a 0 in that location. We want a 0 in that location. And the way to do that is we're going to follow this, we're going to take it from this point to and then explain this one in part 2 of our presentation. So in my next presentation, please look for part 2 of this presentation, and then we will continue this problem solving.